Alright, the last video in a series on this bug pathing program. Here we're looking at the bug pathing, and you're going to see that there's almost nothing to it. It's so simple. Most of the work was done in setting up support functions, the user interface, extra classes, and so on. The init method does something simple. It sets the map, it sets the start and end position, sets the current point. In this case, bug is a pathing simulator with a state, and it's a state machine whose value starts with the word free, and it also remembers the closest it's ever been to the end, and it starts out by using self.currentPoint.dist2 to the end. This dist2 meaning distance squared, and it's defined in the vector class that I made. I use distance squared instead of distance because it keeps me from having to use the square root function, which is computationally expensive, at least comparatively speaking, if you're going to do it tens of thousands of times. Okay, and then I initialize the path as empty. I have a function called isOpen, which determines if a tile is traversable. The first one checks if it's on the map or not, and the second one checks to see if the terrain map, self.map, is not 0 at that location. I specify that any value other than 0 is considered traversable. The next step method moves one step. If the state is free, it does one thing. If the state is in follow, it does something else. The free state checks to see if the current direction .direction2, again another of my convenience functions, which takes two positions as arguments, to see if that direction ahead is open, which is to say is traversable and on the map. If it is, then you move ahead. Otherwise, we record the closest we've ever been to reaching the destination, and we set the state to follow. If the state is follow, if we're following a wall, then we continue turning to the right until the way is clear. So for I in range of the length of direction.getVs, here if I'd use direction.vs, I'm pretty sure it would return error. This is the method which is visible to this class, and that's got something to do with variable scoping, and which one is defined first. Maybe. So it tries to rotate right. If the path is open, then it exits the loop with break. Otherwise, it rotates the direction to the right. Having done so, it makes a move, and then turn the moving direction to the left. So it moves ahead and then rotates the direction left. You might say, well, I just found a direction to move in. Why am I moving to the left now? The reason why you rotate left is because your hand is on that wall. And as soon as that wall disappears from under your hand, well, now instead of continuing to move straight, you should be headed left. So in a sense, your priority is left. In the previous video, I said that I had gotten the left and right indicators backwards because I was thinking in terms of a standard right-handed coordinate system. But remember that y values are increasing, going down. Well, that means that everything is mirror imaged. And so I actually got the left and right correct. All right. Then we check to see if self.currentPoint.distance2, remember distance squared, to self.end, that's the goal point, if that distance is less than the closest we've ever been, then it sets the self.state to free. If we're at the end, it sets the state to arrived. So if I were to draw a diagram of the state machine as if I were in a computer science class, there's free, and there's following, and there's arrived. And it looks like the pathing connection is this. The program begins at free, free can go to follow, follow can go to free, and both of these can go to arrived. And there you go. So you come in, you go around, and you go there. I don't know if that was even necessary. Maybe that was a total waste of time. But it seemed like the more teacherly thing to do. Tell me in the comments if you thought it was a total waste of time. But say it nicely, because I'm a person too. Or am I? Okay, we've got a print array function. This was for debugging purposes. It helped me to see what was going on. We've got a move ahead function. It records the tile visit in the MD, the map data file, and that'll be for drawing an arrow. It changes the current point, and it appends the point to a path. This is all sort of storing the same information, but it gets visualized in different ways, so it's worth doing. If you were trying to make this method fast, I think you'd skip a few of these, and you'd just store the path and forget about this map data. Then there's this refinement section, and look how simple it is. There's nothing to it. It goes through the path, and in this section it attempts to make a turn earlier, so make a left turn before you need to, or make a right turn before you need to, and it determines if a left turn or a right turn is present by taking the cross product of two vectors, because you can imagine if I had a vector going ahead and a vector going right, the cross product would be by the right hand rule down, and the other way it would be up, so you'd get a 1 or a -1. If the two vectors were collinear, you'd get a 0. So if I rotate a direction by an amount 1 or -1 or 0, it'll give me the appropriate tile to test. And then I'll try to make that an alternate path. Then I'll look for any repeats, which is to say loops in the path, and cut those out. And that's all there is to it. It's so easy. I use a try and except function here because I was having some errors in this. I say it's easy. The more times I say something's easy, that's the more trouble that it gave me when I tried to make it work. And I'm just trying to convince you that I know what I'm doing by saying that anyway. So that was harder. So because I kept having errors, I would do try and except, and if there's an error which appears here, then it turns the code into this section instead of crashing the program. And one of the things I was doing in that section was I was trying pdb.setTrace. So what is that? Well, let me show you. I can run this example in the debugger mode in the following way: Python -m pdb example6.py. This opens it up in the debugger mode. We start at the first line, and I give it the letter C and return to continue. Okay, and now it's going. And if there were an error, then it would give me control of the program at this point. I've actually already fixed the error, so I don't know that there's going to be one. But maybe I can create an error with Control C from the command line. No, that just finished the program. So I'll quit with Q, and now I'll generate an error. That's easy to do. Self.path at 1,000,000. I mean, that's of course going to be an error. It's array out of bounds. So I'll do continue, and now I'll run. And now I'll press R to refine. And now it says traceback.print_x. So here it's hit this line, and if I want it to go ahead and do that line, I can step with S. So here it's giving me the traceback. Def print exec. So now it's giving me individual lines in the function which prints the traceback. Here's S, file is none, okay, yada yada. Okay, for line and traceback exception, okay, chain init. Here it's going deep into this traceback function. This is all kind of unnecessary. Let's wait until we get to the point where it returns, and then we'll do another part. Okay, at class method, okay, if limit is, look at all these things. So this is telling you maybe more than you want. I actually had no idea there would be this much here. I could do C to continue. Okay, let's just let it continue. Now it got back to here. So it told us the error was on line 85 in refine self.path, and this was the one that we knew would be wrong. It said the list index is out of range. And at this point, we can query things which are visible from this scope. So for example, the value of I is here. So I can see that it was while I is less than self.path minus 2. And I is 1, probably because it got to this line, I plus equals 1. And I can check the value of other things too. I can print v1, and I can print v2, and I can step by bit and see what the values were that caused the error to occur. So this pdb.setTrace can be used in that way, and you might find it useful. All right, thanks for listening. On to the next example.